Shh, guys, eyes up here. Two numbers that multiply to get 35. Who's got them? 5 and 7. Thank you very much. 5 and 7. Are those both prime? Perfect. So I'm going to go ahead and circle those. Two numbers that multiply to get 50. 5 and 10. 5 is prime. Two numbers that multiply to get 10. 2 and 5. Thank you. Circle those. Two numbers that multiply to get 30. Or 5 and 6. All right, two numbers that multiply to get 10. 2 and 5. All right, over here, I'm going to go ahead and I'm going to write these out. So I have 35 is 5 times 7. Remember, your numbers have to go from smallest to greatest. So I have 2 times 5 times 5 for 50. And then for 30, I have 2 times 3 times 5. All right, out of those three numbers, these three areas that they gave us, what number do we have in common? We have a 5 in common. Very good. So I'm going to go ahead and I'm going to circle those. Do you see any other numbers in common?
2. But no, it has no 2 at the top.
Right, 35 doesn't have a 2, so we don't have a 2 in common with all three of those. So 5, it looks like, is our only number that we have. So we only have one 5. So our greatest common factor is going to equal 5. However, you can't forget these variables that are attached to those areas, okay? So let's look at our m's first. What is the smallest exponent that we have on the m's? 4, right? So my greatest common factor is going to be m to the 4th. And then let's look at the n's. What is the smallest number of n's that they all have in common? Very good. They all have at least one n in common.
Can I ask a question?
Yes, please.
Let's say I wrote all the m's out and all the n's out and saw what they had in common just like the old way. Are we going to get counted off for that on the quiz tomorrow if we show all that?
You will not get counted off on the quiz, but we have been working with the shortcut way.
Okay.
So it's up to you, whatever you're comfortable with.
Okay. Thank you.
No problem. Thanks for asking. Okay, so we're going down here now. Use the rectangle model to factor the expression above using the greatest common factor. So, because these are not in parentheses, what does that mean these three numbers are? Our area, right? If we remember our area formula, it's area equals height times width. So we have our area already for each of the rectangles. What is our height going to be? 5 what? Very good. Don't forget all those variables. They're going to be very important for your answer. So our greatest common factor that we get from our areas is always going to be the height. Okay? Now I'm going to go ahead and I'm going to plug in the areas that they've provided for me into the third, -50, m to the 6th n, and 30 m 4 n to the 5th. All right. Now from here, I have two parts of information that I can use to find my width for each of those rectangles. So I'm going to go ahead and I'm going to plug in my height first. 5m to the 4th times blank equals. All right, what times 5 equals 35? 7. Very good. 7. My height has 4 m's. My area has 5. How many does my width need to have? 1. My height has 1 in. My area has 3. How many does my width need to have? Brendan, how many does my width need to have if I have 1 here and 3 here? 2, right? So I'm going to put n squared up there. Okay. Let's go ahead and let's plug that in up here. 7m n squared. Don't forget that you have to complete your picture. So you have to have your area, your height, and your width all written in. Yes.
I'm so sorry, because do we have to have the 5m to the 4th n times like?
Yes.
Do we have to have that work also? Okay. I just want to stress.
Yes, yes, yes. Please show your work. Hey, this is all vital information for you guys to get a 100% on this quiz tomorrow. Good, I'm glad. Yes, ma'am.
I'm gonna be late tomorrow for start, so I might have to come up 6 hours.
Okay, that's fine. Not a problem. Thank you for letting me know. All right. 5 times what equals negative 50?
5 times.
Negative 10, right? We have 4 m's in our height. I need 6 for my area. How many is my width going to have? 2, yes. So I'm going to write m squared. I have an n. I only need an n for my area. How many n's am I going to have in my width? None, right? Very good. All right, don't forget to write it in like I almost did just then. Hi, Mr. McFarland.
Where did m squared come from on the 10?
See how we already have m to the 4th on our height? And then we need 6. So if we multiply m to the 4th times n squared, then we're going to get that 2, extra 2 that we need for our area. Bless you. All right, plug it in. Blank equals. All right, what times 5 equals 30? 6. Very good, thank you. 6. I have 4 m's for my height. I need 4 m's for my area. How many am I going to put over here? None, right? I already have all the, yeah, bless you, all the m's that I need. I have 1 n for my height. I need 5 n's for my area. How many am I going to multiply here? Yep, 4, right? Very good. I'd say plug that in so I show all my work. We're not done yet though, are we? It looks like we are. Our picture is complete, but we haven't written it out yet. So, one more time, remember that the formula for area is height times width. This is my area right here. So what number am I going to put first after the equal sign? Good morning. What, Kelsey? I heard you say it. Very good. That is my height. Just for organizational purposes, I'm going to write H there for myself. And apparently a big old line. And then because I have more than one width, I'm going to go ahead and put it in parentheses. Ignore this. Just pretend that you can see through it. I'll write it up. Don't worry. So let's go ahead and plug it in. We have 7m n squared minus 10m squared plus 6n to the 4th. So you're just plugging all these numbers in down here. That's what we wrote. But is that our final answer?
You gotta do the light box.
Not boxing it yet. Imagine, it's on the tip of your tongue.
Like terms.
Not like terms.
Where the ones that's a light, the same with the same value.
No. What do we have to do with the exponents first? You got it. I know you know it. Do we go from smallest exponent to largest or largest to smallest? Reverse.
Largest?
Largest to smallest, right?
You said. Remember you told me it goes smallest to largest.
Okay, so if you're
Just switch up.
if you're finding the amount that they have in common, then you're looking for the smallest. If you're writing them in order, then it goes from largest to smallest.
But see, this confusing.
There's a lot to remember, isn't there, for this one? All right, so let's go ahead and write this out so it's finished. Which one has the largest exponent of the three widths? Which one, Elizabeth?
6 and 4.
Thank you. 6 and 4. Which one has the next largest amount? Remember, this counts as a 1. So we would have 1, 2, 3 here, and then we would have 1, 2 here. So which one has the next largest amount of exponents? 7. Yep, very good. Plus 7m squared. And then we would have minus 10m squared. Close my parentheses and box my answer. Okay, so let's rehash that one more time. So when you are writing these in order for your final answer, you are going to write the largest exponent to the smallest exponent. But remember that each of the variables has at least, if it's by itself, that means that it's 1, okay? So in this instance, we did the 4, the 3, because this one pretended has a 1 there, and then we went 2. If this one had a 4, this had no exponent here, so pretend this 2 wasn't here, and then this m squared was here, we would still have 2 here and 2 here, but we would need to go in alphabetical order. So we would do 6 into the 4th, negative 10m squared, 7m in. Okay? I know that might be a little bit confusing. But just always remember that it's biggest exponent to smallest, and then it goes in alphabetical order. All right? And you can always use your notes as well. All right, let's flip it on over. Because we're not done yet. What did you say, Deontay?
I said, y'all just not
You
I thought y'all was done.
mumbling over there in the
I
corner?
thought we was done with that.
No, where's your opener?
You want it?
Are you done with it?
Yeah.
You have a lot of work on the front that you didn't show.
I know. I don't never show with it.
I know you don't. Well, if you want to turn it in, that's fine with me. All right. We're finding the greatest common factor of the terms in each of the following expressions. Two numbers that multiply together to get 20. 2 and 10. Thank you. 2 and 5. Circle those. Two numbers that multiply together to get 36. Elizabeth. 6 and 6. Good.
And for the 6 and 6, it's 2 times 3.
Thank you. I'm going to go ahead and I'm going to write these out. So for 20, I have 2 times 2 times 5. For 36, I have 2 times 2 times 3 times 3. Numbers that both of those have in common. Elizabeth. 2 and 2. Elizabeth, we kind of just shout out in this class. So if you want to just...
See 6 arms, so I used to raise my hand.
I know. So if you just want to shout out, that's totally okay too. So I have 2 and 2. I have 2 2s. So what am I going to do with these 2 2s that I have in common? Multiply. To get 4. So my greatest common factor is going to be 4. But then let's not forget my variables. So I have s cubed. Very good. And then what? T. Thank you very much. So my greatest common factor is going to be 4s cubed t.
QT.
QT.
That's crazy.
All right, let's go ahead and do 60. 2 numbers that multiply to get 60. 6 and 10. 10 is 5. What? 20 and 3? Oh, okay, I get what you're saying. I was like, I don't know what you're talking about. All right, they did 96 for us already. That was nice. Do you guys have 96 done on yours? Okay, perfect. And then 36, we already did up top, so we know it's 6 and 6. 3 and 2. 3 and 2. Always circle those prime numbers, please. That's going to be part of your work. So 60 is 2 times 2 times 3 times 5. We have 96 as 2 times 2 times 2 times 2 times 2 times 3.
We gotta do that. We gotta do that.
This part? Yeah, because that's part of your work that you got to show. And then 36 is 2 times 2 times 3 times 3. All right. What numbers do all of those have in common? 2.
2 in a row. 2.
Another 2. And a 3. Any other numbers in common?
No.
Nope. We're good. So our greatest common factor is going to equal 2 times 2 times 3, which is what? 12. And then let's go ahead and look at our variables. U5, U6, U2. What's our smallest one that they give us? U2. Very good. All right, what about these?
The V is by itself.
Just the V.
The V that's by itself. Very good. Because even though these have big exponents, we have this one that is super small. All right, and for W's,
The 5.
W to the 5th, right? Because it's the smallest exponent. Box your answer. Woohoo! Nice work. When you guys are good with that, go ahead and pass those over to Mr. McFarland. Sorry, I don't know why I handed those to you.